Hi and welcome to my video on choosing colors and color palettes for data visualization. In the field of data visualization, one of the most important aspects to consider is the use of colors. Today, I'd like to take the time to share with you the different color palettes you can build to bring out the effectiveness of your data visualizations. Why are colors important? Colors can help communicate information effectively, improve readability, and create an overall visually appealing experience for the audience. A good set of colors will highlight the story you want the data to tell, while a poor one will hide or distract from the visualization's purpose. Let's now go through the types of color palettes you can choose from that best fits your use case. The first type of color palette I'd like to introduce is the qualitative color palette. This type of color palette is best used to explain categorical data. This type of data can be divided into groups, and some examples include gender, of the male, female, and others category, car types such as the SUV category, sports category, and the hatchback category, and for types of soft drinks such as Coke, Pepsi, Sprite, and 7-Up. When using a qualitative color palette, consider limiting the number of distinct colors to 10 or less to avoid distracting the user from understanding the main point. If this is not possible, consider grouping values into an umbrella category such as others. In this case, we have a pie chart with 14 colors, and by grouping together all the smaller slices into the others category, we can obtain a pie chart with about 7 colors. In order to obtain distinct colors, you can adjust the hue as well as the lightness and darkness of color. In the first vertical color palette, we have colors of different hues, making it to be a pretty good qualitative color palette. But in the second color palette, some of the colors have had their lightness adjusted. But one thing that stands out is the first red color, which had not been adjusted. So do note that having too much of a difference in color might falsely inform the user that one color is more important than the other. Another thing that we will try to avoid is to have 2 or more colors with the same hue, but different lightness and saturation. In the third color palette, we can see that the blue hue is repeated 3 times in different saturations, unknowingly suggesting an association. On the topic of association, the second type of color palette I'd like to discuss would be the sequential color palette. This type of color palette is best used to explain numerical or ordinal data, and it is a type of ordered data where one allows for arithmetic and the other doesn't. Some examples include t-shirt sizes such as small, medium, large, fan speeds from low, medium to high, and top 10 movies ranked accordingly, such as rank 1, rank 2, all the way to rank 10. The sequential color palette is based on a continuum and uses lightness and saturation to achieve the colors. It may be coupled with hue differences to show the ends of the spectrum, and this will be explained more in the next type of color palette. This color palette is effective as it is easy to discern what the lower and higher values are respectively. The lower values typically correspond to lighter colors, and the higher values correspond to darker colors. Of course, this can vary based on the domain of your data. In order to introduce an added layer of dimension, you can consider using a multi-hue palette over a single hue one, which is what I showed you earlier. The third and final type of color palette I will be discussing is the diverging color palette. This is useful for numerical values with a central point, and this data type involves numbers upon a scale that includes 0. Some examples include temperature, ranging from negative degrees Celsius through 0 all the way to positive degrees Celsius, and in this case, user opinion, ranging from -5 all the way to 5, passing through 0, where 0 could be a neutral value. In a nutshell, the diverging color palette is essentially a combination of 2 sequential color palettes. One this way, and one this way. A hue is assigned to each ends of the color palette to represent 2 opposing values, and the hues decrease in value as they approach the center of the color palette. The center colors are usually lighter in nature. And now, after going through type 2 sequential and type 3 diverging palettes, it is a good time to look at the difference between these discrete and continuous palettes. Now let's go over the differences. With regards to the ability to distinguish marks, discrete palettes are easier in distinguishing marks apart, and it typically exerts lesser cognitive load on the reader. For continuous palettes, although distinguishing is harder, it has benefits when it comes to intuitively showing the reader a continuous association. When it comes to the ranges for both types of palettes, their differences can be seen clearly. If your dataset has outliers, continuous palettes suffer as the entire continuous color range is forced into a narrower range to accommodate an outlier. This makes it difficult to see the differences of values for non-outliers. As you can see, the color differences are almost non-existent. Discrete palettes, on the other hand, can handle this by setting the range buckets for each color into an uneven range distribution, keeping the integrity of the chart and encapsulating outliers. Last but not least, because of the ability to set uneven ranges, discrete palettes make it difficult to compare elements within the same range, while continuous palettes allow us to compare the minute differences of the elements. Wrapping up the tips section, if there's anything you should take away from this sharing, it's these 5 tips. Tip number 1. Avoid unnecessary usage of color. Remember that color serves to inform and not distract. Tip number 2. Be consistent with colors across charts. Stick to colors specified in legends, and if possible, match the colors between charts if they refer to the same group or entity. Tip number 3. Leverage meaningfulness of colors. Use colors that are associated with the type of data and background of data. For example, the F1 constructors in this chart are colored according to their team colors. Other examples include such as Milo, signature green, and a glass of beer where the color could be the color of the beer. But we must take note of the cultural differences in our target audiences. Red is prosperity to some, but danger to others. So it is these kind of examples that we need to take note of when coloring our charts. Tip number 4. Use color theory and psychology. Green is generally associated with the keywords good, profit, increase, positive, and red is generally associated with keywords such as bad, negative, or declining. So by understanding color psychology, we can leverage on these color styles and use them appropriately in our charts. Tip number 5. Accessibility for color blindness. It would be best if your visualization accounts for color blindness to ensure that your visualization can have the same impact on a wider audience. And you can achieve that by using tools available on the internet to help simulate color blindness. Here's one such example where you could drag and drop and paste your file and select the type of color blindness or the views that are available on the color blindness simulator, and you can see how well your chart still stands out or communicates the information. Besides using tools for color blindness, some online tools can also help with finding the best color palette for your visualization. These tools can come in a variety of complexity and will help you be more effective in picking the best colors for your charts. These tools can simulate what a chart may look like with your selected colors, and for the more complex tools, allow you to tweak the nitty-gritty of colors as well as exporting the hex code for use in your D3 or Plotly charts. For more information about the tools you can use, take a look in the description of the video or find the references in my supporting document. And with that, I have come to the end of the video and I hope you learned a thing or two about color in data visualization. Thank you.